Hello everyone, and welcome to your video on how to calculate the length of an arc. So I've drawn a circle here, and we have a 90-degree angle, a central angle going right there with the vertex in the center. And what we are looking for is this portion of the circumference that I've labeled in black. So if you could imagine that, we want to put a little fence up right here. How much fence do we need? Now, that is not really an easy question because usually when we measure things like length, we're measuring straight lines. But this is definitely not a straight line. It is a curved line. So we have to do some funky calculations. So we know that this angle is 90 degrees. We also know that our radius equals 5. We're going to call that 5 feet. And so we want to know how many feet this arc is. So this will look familiar to you, at least I hope it does. So the first thing that we need to do is we need to calculate the circumference of the entire circle. And our formula for circumference is c d pi. C d pi, I see d pi. Right, that's so that you remember it forever. Okay, so c d pi says that that is our formula. So circumference is going to equal our diameter, which, be careful, is 10. It's 5 plus 5 more, 10 pi. So our circumference is exactly 10 pi. Now, just for the sake of, understandability, I will say that that is about 31.4 feet. Because we decided that we were going to measure in feet this time. It's not exactly 31.4 feet. It's exactly 10 pi. But 10 pi is very close to 31.4. All right, so then our next step is to say, okay, so the arc length is going to be 10 pi over 1, that's just our circumference that we already calculated, times 90 over 360, because we're doing 90% or 90 degrees out of a 360-degree circle. So, again, I'm a big fan of canceling when possible, and it's just too easy not to in this case. So I get 90 pi over 36, and if I try to do 90 divided by 36, I get 2.5 pi, which is a pretty nice number. That, by the way, equals about 7.9 feet. So that gives you some idea of how this sector is related to the whole thing. You should also be thinking in your head, 90 degrees, that's 1/4 of the sector. So it should be about 1/4, which it is. All right, let's do another one just so that we know what's going on. Here's our circle. This time, we're going to measure in miles, and we know that we have a 12-mile radius, and we also know that we have a 2-degree angle. So the first thing that we're going to do is we're going to calculate our new circumference. C d pi tells us that our circumference is going to be 24 pi. Again, make sure that you're calculating the diameter, not just the radius. And 24 pi, for those of you who are interested in such things, is about 75.4 miles. So that's a pretty big area to work with. However, the length of our arc here is not going to be nearly that long. That is going to be 24 pi over 1 times 2 over 360. And so that's going to give us 48 pi over 360. And if I reduce that, because when I put it in my calculator, I do not get a nice number. I get an ugly number. So instead, I'm just going to reduce it. You know, first I'll divide by, probably 6, and then I'll probably divide by 2, and then I'll probably divide again, and eventually I will get to 2 pi over 15. 2 pi over 15. So that's 2 times pi equals divided by 15 equals, so that is about 0.4 miles. So that's much smaller, isn't it? Yeah, it sure is. Okay, so that is how you calculate the length of an arc. It is extremely similar to calculating the area of a sector, but this focuses on circumference because we're just measuring that edge. All right, that's all there is to it.